Okay, so we do common factoring. Common factoring, what you're looking for is similarities between different terms, okay? So there's actually two major terms here, and the way we determine if there's a term is we look for addition or subtraction signs. In fact, we can make this question a little more complicated. Why not? That's always fun, right? Let's add a subtract. Hi, honey. Let's add a subtract 8x 4y 10. Okay, so now we have 1, 2, 3 terms, and the subtraction and addition is what separates terms. Technically, this is 4 multiplied. Multiplication and division, they don't subtract, or sorry, they don't separate terms. Close that door, okay, guys. Thank you. So what we're looking for is common terms. So we can actually find a whole bunch of common terms here. First, we're going to go with the coefficients. We got a 4, a 12, and it's nice to actually look at this as -8 and actually +12. We're going to look at them that way. There's the variable x, so we need to look at what the power is attached to that x. So there's an x in each of the equations, and there's very conveniently a y in each of the equations. And in fact, I just want to make sure we get another scenario in here. I'm going to add a z3, okay? Z being its only one, we'll still highlight it. Can I highlight it in black? Oh, it's gray. Okay, good. Okay, so we've got all of our terms here. We put them together. The next thing we want to do is look for common factors of all of these. So a factor is another set of numbers that you can multiply to get these. So our coefficients, we have 4, 12, and 8. There's lots of ways we can do that. Essentially, you can kind of make like a factors chart on the side. I can say 4, 8, 12. Write all the factors of 4. Well, there's 1, 4, and 2. For 8, there's 1, 2, 4, 8. For 12, there's 1, 2, 3, 4, 6, 12. As you get better at this. You could take any of the common factors, but it's actually easiest to take the greatest common factor. That way you're done all in one shot. So our greatest common factor here is actually the value 4 here. So 4 occurs in all 3 of these. Perfect. We're gonna make divide each term, and each term is gonna get divided by 4. So that's the coefficient we divide each one by. And then we're also gonna find an x variable to divide everything by and a y variable. We're not going to find a z variable because z only occurs in the last one, and because it's not common in each term, we actually can't common factor out. It has to occur in every single term. So x. The way to tell for variables is you actually just look for the lowest exponent, okay? So we have a 5 exponent, a 3 exponent, and a 4 exponent. So we're actually just going to divide by x cubed. That's the lowest valued exponent. So we say x cubed is the value we're going to divide by. And what does that mean for y? What would be the lowest y value exponent here?
Y squared.
Y squared, perfect. So we're also going to divide by y squared. And again, are we going to use the z or the z value? No, it doesn't show up. So this is going to be our common factor. So before we do any dividing, I'm going to move this down just a little. Oops, did the whole thing. I guess it's going to have to. Let's erase this. What we're going to do is I'm going to write the common factor out first. I'm going to write it in front of a set of brackets. So 4x cubed y squared. Keep in mind that that's what we common factored everything by. So we have a new set of brackets. Oh, and there's going to be 3 terms we're going to set into the brackets. So I will kind of underline it. I guess we'll use yellow here. Term 1 will go here. Term 2 will go here-ish. And term 3 will go here-ish. So even though we common factor, there's still going to most likely be the same number of terms within this set of brackets. This value on the outside is just telling you what we divide each of those terms by, okay? So now we just go through the division. 4 divided by 4, well, that's just 1. So we have 1. X to the power of 5 divide x to the power of 3. We subtract the exponents. What are we going to get here?
2.
Yes, perfect. So x squared. And y divided by 2, divide y divided by 2. What are we going to get here? It's a little tougher.
It cancels out?
Yeah, it cancels out. It technically creates the value of 1, so we multiply by 1. But anytime you multiply something by 1, it keeps the number the same. So there's no real reason to write it in. In fact, the one in the front, I actually don't need to write that one either. It's really just going to be x squared, okay? Our next value, what is positive 12 divide positive 4?
3.
Yeah, so we're going to write positive, because it is positive 3. And then x3, cancel out, right? Makes a 1. Y squared, cancels out, makes a 1. Great, so the term just becomes 3. Finally, negative 8 divide 4.
And negative 2.
Great, so we're going to say negative 2. X to the power of 4 divide x to the power of 3.
Is x to the power of 1.
Do we need to write the 1?
No.
No, there's no need to it, so we just leave it as is. Y10 divide y to the power of 2.
1, 8.
Yeah, and what do we do with the z?
You bring it down.
You bring it down. Think of it as if, I know we didn't quite do it, we can say that you're dividing z cubed, or z to the power of 3, by 1, and when you divide by 1, it's just going to keep that number the same if it helps you, visualize that better. So we're just going to write the z cubed. So let's rewrite our final answer so it's not so spaced out here. Our common factor was 4x cubed y squared. The first term in the brackets was x squared plus 3 minus 2x y to the power of 8 z to the power of 3. And that's it. That's essentially common factoring.